Okay, so now I want to just sort of talk about eccentricity of an ellipse. And so eccentricity is C divided by A, which is going to be the focal length divided by the semi-major axis. And is how round or squashed is the ellipse. Okay, so if we go back to sort of my original ellipse that I started with, we basically, we set this up and we ran this along, and we just sort of ran our pencil along this thing here, and we came up with that our semi-major axis was going to be 10.9, and our focal length was 6.1. And so I grab my calculator. And I see that this has an eccentricity of 0.56. So there's just sort of a nice ellipse with a 0.56. Okay, so let's look at what the limits are. So 0 is less than or equal to, let's just get that out of the way for a second. 0 is less than or equal to, the eccentricity is less than or equal to 1. Because in this case, so eccentricity equals 0 means that C is equal to 0. And an eccentricity of 1 means that C is equal to A. And so let's look at those two limits here. So first one, C is equal to 0. Well, what does C equal to 0 mean? Well, what that means is I take my pin and I make a focal point, and then I take, on the other end of my string, I take a pin and I make it the same focal point, and I put them right back in there. So I've got the distance between my focal points is 0. Well, if the distance between my focal points is 0, then what do I got? I've got a circle. Okay, so eccentricity equals 0 means you have a circle. Two foci in the same place. Okay, and then if I look at C equals A, well, what's that going to look like? Well, what that means is I'm going to take, I'm going to take a focus and place it right there. And I'm going to take another focus and I'm going to place it right there. And I go, wait a second, but I can't really, and that's the whole point, that I just sort of draw along there. And so this is an ellipse, okay? This line is an ellipse with E equals 1. Okay, so if your eccentricity is equal to 0, you get a circle, two foci in the same place, and here you've got two foci as far apart. How do I want to say that? So I take the two foci, put them as far apart as the sum of the distances, and then the only points that satisfy that, the definition of an ellipse, which is, remember, the definition of an ellipse is the set of all points a given whose sum of the distances to two fixed points is a constant. So any point along that line solves that if the two focal points are as far apart as the sum of the distances. And then here I've got a circle if the two focal points are in the same place.